Hi students, this is Dr. Joe Engley, and in this lecture we will continue to explore how humans use the Earth's water resources. The World Health Organization considers an average of 1,000 cubic meters or 264,000 gallons of water per person per year to be a necessary amount of water for modern domestic, industrial, and agricultural uses. It's fairly common in some areas to use 70% of annual river flows, and in a few cases, to use as much as 120% of annual renewable resources by drawing on fossil groundwater. This obviously isn't sustainable in the long run, and about a third of the world's current population lives in countries where water supplies don't meet everyone's minimum essential water needs. The biggest problems in water stress and scarcity at a human level occur in Africa and Asia, where rainfall is low and poor countries can't afford to adapt. Notice that the scarcity map shows average conditions for each country. Local conditions, such as those in the American Southwest, can be much worse than the countrywide mean. This figure shows freshwater availability in cubic meters per person per year in 2007. Note that China is vulnerable to water shortages due to drought in its northern and western regions, even though its southeast has been suffering catastrophic floods. Not surprisingly, the biggest problems in water stress and scarcity occur in Africa and Asia. More than two-thirds of the world's households have to fetch water from outside the house. This is heavy work done mainly by women and children, and sometimes taking several hours per day. Improved public systems bring many benefits to these poor families. The hours once spent carrying water um, is often poor, and increased sanitation could dramatically reduce infectious diseases. There is no single definition of drought. What would be an amazingly wet year in a desert might be considered a catastrophic drought elsewhere. In general, a drought is an extended period of consistently below average precipitation that has a substantial impact on ecosystems, agriculture, and economies. The worst drought in recent United States history, in economic and social terms, was in the 1930s. Poor soil conservation practices and a series of dry years in the Great Plains combined to create the quote unquote Dust Bowl. Wind stripped topsoil from millions of hectares of land, and billowing dust clouds turned day into night. Thousands of families were forced to leave farms and migrate to other areas, as the opening, as such as California. Droughts in the American Southwest aren't a new phenomenon. In fact, the dry spell in recent years have been relatively short duration compared to historic events. The Dust Bowl of the 1930s, for example, only lasted about 6 years. By contrast, the mega droughts that destroyed the Anasazi or ancient Pueblo cultures that we see in this figure in the 12th and 13th century lasted between 25 and 50 years. In many areas of the United States, groundwater is being withdrawn from aquifers faster than natural recharge can replace it. On a local level, this causes a cone of depression in the water table. On a broader scale, heavy pumping can deplete a whole aquifer. The Ogallala Aquifer underlies 8 Great Plains states from Texas to North Dakota. This porous bed of sand, gravel, and sandstone once held more water than all the fresh water in the region. However, so much water has been extracted over the last 100 years that wells have dried up in many places, and farms, ranches, even whole towns are being abandoned. Recharging many such aquifers will take thousands of years. Using quote unquote fossil water like this is essentially water mining. For all practical purposes, these aquifers are non-renewable resources. In the background figure from NASA's National Drought Mitigation Center, we see unusually low groundwater storage levels in Texas in 2011 and in the central Ogallala aquifer area. A photo taken in 1977 shows subsidence caused by groundwater pumping in California's San Joaquin Valley. The 1925 sign indicates the ground level in that year. Too much water withdrawal allows aquifers to collapse, creating a subsidence event, which is the sinking of the ground surface. The San Joaquin Valley in California has sunk more than 10 meters or 33 feet in the past 50 years because of excessive groundwater pumping. Where aquifers become compressed, recharge becomes impossible. Another consequence of aquifer depletion is saltwater intrusion. Along coastlines and in areas where saltwater deposits are left from ancient oceans, overuse of freshwater reservoirs often allows saltwater to intrude into aquifers used for domestic and agricultural purposes. Saltwater intrusion has become a significant issue in Florida along the southeast coast, where we've had to relocate water wells to the interior Everglades. Dams and canals are a foundation of civilization because they store and redistribute water for farms and cities. Many great civilizations have been organized around large-scale canal systems, including ancient empires of Sumeria, Egypt, and India. As modern dams and water diversion projects have grown in scale and number, though, their environmental costs have raised serious questions about efficiency, costs, and the loss of river ecosystems. More than half of the world's 227 largest rivers have been dammed or diverted. Of the 50,000 large dams in the world, 90% were built in the 20th century. Half of those are in the largest water diversion project in the world, which was recently built in China. That moves more than twice the flow of the American Colorado River. The initial cost estimate for this scheme is estimated to be $62 billion, but could easily be twice that. However, the Three Gorges Dam project is vital to the capital of China, which is Beijing, where more than 20 million people live. This is the Three Gorges Dam, which is the largest dam in the world. It has recently caught the attention of NASA scientists because there is a possibility that it interferes with the rotation of the Earth. This colossal structure, made by human hand, is located in Hubei province and is considered the largest hydroelectric power station on the planet. International Rivers, an environmental and human rights organization, reports that dam projects like such as these have forced more than 23 million people from their homes and land, and many are still suffering the impacts of dislocation years after it occurred. Often the people being displaced are ethnic minorities. Currently, at least 144 dams on 8 rivers in Southeast Asia have been proposed or are under construction. This includes the Langkang, which is the upper Mekong, the Nu in the upper Salween, and the Jisha in the upper Yangtze. Several of these projects are in or adjacent to the Three Rivers World Heritage Site, threatening the ecological and cultural integrity of one of the most spectacular and biologically diverse areas in the world. Hoover Dam powers Las Vegas, Nevada, and Lake Mead, which forms behind the dam, supplies drinking water to the city of Las Vegas. However, this lake loses 1.3 billion cubic meters to evaporation every year. And now, reduced inflows threaten the viability of the entire Colorado water system. Therefore, Las Vegas is facing a dire situation with the drying up of Lake Mead. Therefore, it started a $3.5 billion 525-kilometer pipeline to tap aquifers in the northeastern part of the state. They're also digging a $3.5 billion tunnel that will bury into the bottom of Lake Mead 100 meters below the normal outlet, so that even if the lake reaches the dead pool level, as warned by the beginning of this decade, the city will still be able to draw off water. One of the most disastrous diversions of water in world history is that of the Aral Sea. Situated in arid Central Asia, on the border of Kazakhstan and Uzbekistan, the Aral Sea has a shallow inland, it was a shallow inland sea fed by rivers from distant mountains. However, starting in the 1950s, the Soviet Union began diverting these rivers to water cotton fields and rice fields. And gradually, the Aral Sea has evaporated, leaving vast, toxic salt flats. In this slide, we see changes in water levels and extent of the Aral Sea over a period of 34 years from 1975 to 2009. Notice that in the sea, once able to accommodate ships, has been significantly reduced in size. Many environmental scientists have warned that water shortages could lead to wars between nations. Fortune magazine wrote, "Water will be to the 21st century what oil was to the 20th." With 1/3 of all humans living in areas with water stress now, the situation could become much worse as the population grows and climate change dries up some areas and brings more severe storms to others. Already we've seen skirmishes, if not outright warfare, over insufficient water. In Kenya, nomadic tribes have fought over dwindling water and grazing. An underlying cause of the genocide now occurring in the Darfur region of Sudan is water scarcity. When rain was plentiful, Arab pastoralists and African farmers coexisted peacefully. Drought, perhaps caused by global warming, has upset that truce. The hundreds of thousands who have fled to Chad could be considered climate refugees as well as war victims. Although they haven't usually risen to the level of war, there have been at least 37 military confrontations in the last 50 years in which water has been at least one of the motivating factors. Water can also be used as a weapon. Saddam Hussein cut off water flow to the massive Iraq marshes as a way of punishing his enemies among the marsh Arabs. Drying of the marshes drove 140,000 people from their homes and destroyed a unique way of life. It also caused severe ecological damage to which is regarded by many as the original Garden of Eden. Climate change-induced drought also appears to have been a contributing cause of the Syrian conflict. In this figure, we see the deficit or surplus of water in the Mediterranean region. Reds and oranges highlight lands around the Mediterranean, indicate areas that experienced significantly drier winters from 1971 to 2010 than the comparison period of 1902 to 2010. Some authors have noted that climate change and water scarcity has played a significant role in the Syrian conflict. Syria's current social unrest is, in the most direct sense, a reaction to the brutal and out-of-touch regime and a response to the political wave of change that began in Tunisia in the early months of 2011. This is not the whole story. The past few years have also seen a number of significant social, economic, environmental, and climate changes in Syria that have eroded the social contract between citizen and government in the country, strengthened the case for the opposition movement, and irreparably damaged the legitimacy of the Assad regime. From 2006 to 2011, though, up to 60% of Syria's land experienced, in the terms of one expert, quote, the worst long-term drought and most severe set of crop failures since agricultural civilizations began in the Fertile Crescent many millennia ago, unquote. This led to a massive exodus of farmers, herders, agriculturally dependent rural families from the Syrian countryside to the cities, massive internal displacements from rural to urban centers, and significant discontent among agriculturally dependent communities are some of the ill-explored factors of social and political unrest in Syria. This is obviously a complicated environmental, social, and political situation, but it's increasingly clear that global and regional climate changes have played a role in multiplying the stress in the region. This figure shows predicted changes in precipitation for the period 2081 to 2100 relative to 1986 to 2005. This map represents the average of 35 different models with representative radiant forcings of 8.5 watts per square meter. With rising temperatures and evapotranspiration, modest increases in precipitation may not mean increased availability of water resources. However, increased water stress is predicted for the Mediterranean, the Caribbean, Mexico and California, and South Africa.